In this lecture, we want to learn about how to solve quadratic equations. In order to solve a quadratic equation, there's four methods out there in general. One is called method of factoring, which we're going to be discussing now. And then there's another method called the square root method. And then we have this quadratic formula method, where we are using a formula actually to solve quadratic equations. And then we have a graphing method of solving quadratic equations. So one by one, we're going to discuss all of these four methods of solving quadratic equations. We start with the factoring method, okay? So we have a quadratic equation here, and we want to solve for x. The method we use is called factoring. So we have learned how to factor polynomials, in particular quadratic relations. And we're going to use that skill of factoring to solve the quadratic equation. This is a quadratic trinomial that can be factored by decomposition method or other methods we have discussed in the past. So I'm going to look for two numbers that add up to negative 21, and the product is negative 100, because 5 times negative 20, that's negative 100. So what are those two numbers that add up to negative 21, but when you multiply them, it gives you negative 100. So we may try different combinations. For example, negative 1 times 21. Negative 100 times 1. The product is negative 100. But when you add them up, it doesn't give you negative 21. Then you try negative 2 and 50. The product is negative 100. But when you add them up, it doesn't give you negative 21. So then you try like other combinations, such as negative 4 times positive 25. So negative 4 times 25 is, of course, negative 100. But when you add them up, it's positive 21. But we have negative 21. So that means that we must consider negative 25 and positive 4 as the combination we are looking for. Because these two are the two numbers that when you add them up, it gives you negative 21. But when you multiply them, it gives you negative 100. So now that we found these two numbers, we are going to decompose or break down the middle term. So instead of negative 21x, we are going to write negative 25x plus 4x. We have learned this technique of decomposition in the past. It's a technique of factoring polynomials, actually quadratic trinomials. And then minus 22 remains unchanged. 5x squared at the beginning remains unchanged. That's step 1 of factoring. Step 2, we look for common factors between the first two terms and last two terms. So we end up with 5x times x minus 5. And then we end up with 4, which is the common factor between the last two terms. So that is x minus 5 equals 0. And then in the next step, we look for the common factor as a binomial, which is x minus 5 in this case. So we end up with 5x plus 4 equals 0. Making a long story short, we factor the given quadratic trinomial. Now that we factored, we have something times something else equals 0. Now that 0 on the other side is very important. If you think about it, when you have two numbers and their product is equal to 0, logically speaking, either the first one must be 0 or the second one must be 0. For example, 0 times 5 is 0, and 6 times 0 is also 0. So either the first or the second number must be 0, otherwise the product will never be equal to 0. We all know that any number times 0 is equal to 0. So this is also true for polynomials or binomials, not only true for numbers. And if this happens, if a times b is equal to 0, then we say either a is equal to 0 or we say b is equal to 0. Okay, so this is an important property known as zero product property in mathematics. So ZPP, okay, zero product property, which is actually the foundation of this method. We are saying that if the product of two binomials, or the product of a monomial and a binomial, or generally product of two numbers, if that is equal to 0, then in that case either the first or the second number or term must be equal to 0. That's what ZPP is all about, zero product property. So here I'm going to say either x minus 5 is equal to 0, so that 0 times 5x plus 4 has become 0. Or if that's not the case, then maybe 5x plus 4 must have been 0. And then that 0 times x minus 5 has resulted as 0 on the right-hand side of the equation. So either this or that. If x minus 5 is 0, then we are getting x equals 5 as one of the roots or solutions to this quadratic equation. Or if that's not the case, then we have 5x equals negative 4. Dividing both sides by 5, we get x equals negative 4 over 5 as the other solution to this quadratic equation. So the quadratic equation given at the top, 5x squared minus 21x minus 20 equals 0, has two roots or solutions. One is x equals 5, the other one is x equals negative 4 over 5. Sometimes the answers are just integers, sometimes the answers are fractions or even irrational numbers sometimes. If we plug in these two numbers in our equation, left side should equal to right side. In other words, these roots must satisfy the quadratic equation. Otherwise, we have solved the problem incorrectly. So that's how we can check by substituting these numbers instead of x in the equation that is given. Then left side equals right side will show that we have solved the equation correctly. But if you plug in 5, let's say, and left side and right side are not equal, it means that this answer you got does not satisfy the equation, so it must be a wrong root. So we might have made a mistake somewhere. We have to review our calculations. Next one, it says x squared minus 9 equals 0. It's a very famous, equation because you can use the famous difference of squares technique of factoring. So the way I factor this is x minus 3 times x plus 3, set it equal to 0. According to zero product property, either x minus 3 is 0 or x plus 3 equals 0, clearly. So I get x equals 3 or x equals negative 3. Okay? So there are two roots for this quadratic equation. I can check it. I can do a quick check here. I can say left side is x squared minus 9. And when I'm plugging in 3, 4, x, I end up with 9 minus 9, which is 0. And the right side happened to be 0 as well. So left side is equal to right side. And this root I got satisfies the equation. If I plug in negative 3, it will be negative 3 squared minus 9. Once again, it's going to be 9 minus 9, 0, which again satisfies with the right side. So here we got left side equals right side, and here again left side equals right side. So our answers, 3 and negative 3, are correct. This other example, it's another quadratic trinomial. We want to solve quadratic equation. We want to solve it by factoring. So the way we factor this is using the sum and product method. So as you recall from the past, we open and close two empty brackets. We place x inside each one of them, and we look for two numbers that add up to negative 1, the coefficient of x, and their product is negative 42. So I would say negative 7, positive 6 is the answer. So negative 7 and positive 6. Add them up, it's negative 1. Multiply, negative 42. So now that we factored it, we're going to use the ZPP, zero product property. So we're going to say either x minus 7 is 0 or x plus 6 equals 0, which in turn will give us x equals 7 or x equals negative 6 as the final answer. So this is how we solve quadratic equations by the method of factoring. Of course, there are cases where the trinomial cannot be factored. So in that case, perhaps we have to use other methods of solving quadratic equations by. But if it is factorable, if the quadratic trinomial is factorable, or this quadratic binomial is factorable, then we can use this convenient method of solving the quadratic equation by the technique of factoring. In the next lectures, I'm going to discuss how we solve quadratic equations using other techniques. Okay, thank you.